Okay, guys, so if you want to get an idea, a better idea of what these slack variables do, watch videos 4 and 5. All right. My table that I have here to fill out for video 4, it says for each point labeled A, B, C, D on the graph of this system, identify whether the slack variable is positive, negative, or 0 for each constraint. All right. So what we're going to do, these are all referring to this picture, by the way, all right, our original picture. You might have noticed that I just have points all over the place. And this is why. So for A, right here, my slack variables, all right, if this point happens to actually suit the restrictions that I have on the particular line that I'm talking about, then the slack variables for that particular line will be positive, all right? So what I mean by that is that for A here, all of these lines were supposed to be beneath them, all right? Because this says less than or equal to, less than or equal to, less than or equal to, even when we get it into slope-intercept form, all right? Now, point A is actually below all three of those lines. That means it is positive for all three, all right? It is, in fact, below line 1, line 2, and line 3, all right? Point B in opposition is actually not meeting any of the constraints, right? It is not below line 1 or line 2 or line 3. That means that the slack variables for every single line there are going to be negative. Now we can have different combinations of this though. If I look at C, right? C does actually meet the requirement for line 1. It is below line 1. So that means the slack variable, S1, that is in the equation that goes with L1 is going to be positive, all right? However, it does not meet the requirements that it be below line 2 or below line 3. That means that the slack variables are going to be negative for each of those, all right? So when do we get this 0 situation, all right? If I go to D here and I look at point D, all right, the slack variables are going to be 0 when they actually fall on the lines. So L1 and L2 or L3 are both going to have slack variables of 0 whenever I look at point D, all right, L1 and L3, because it actually falls within the lines. If I were to plug that point into the equations for L1 and L3, I would get that I needed to add nothing to get that constant that was on the other side of the original inequality. All right. And finally, for L2, what do you think? We've got, it's above L2. It's not supposed to be above L2. That means this slack variable will be negative. All right. So that's why whenever I look at a system that is all less than or equal to inequalities to begin with, I need all of the slack variables to be positive in order for it to work. Positive or 0. Okay.